We talked about this stuff before, guys, including 6-7 slope intercept forms. I'm going to zip right through that and the inquiry lab on slope triangles. All right, they start us off with a real-world link with football. They say that interception is when a defensive player catches a pass made by an offensive player. It tells us that in a non-proportional linear relationship, the graph passes through the point 0b, or the y-intercept. And we've talked about this before. We said y equals mx plus b is slope-intercept form. M is our slope, and b is our y-intercept, because that's the point 0b. All right, and we said that that's where the line crosses the y-axis. So what they want us to do here is to complete the steps to derive the equation for a non-proportional linear relationship by using our slope formula. All right, so what they want for us right there is our y2 minus y1 over x2 minus x1 equals m. And what they want us to use for this, so they give us 0b, and they give us xy. So they want us to use for y2, y, for y1, b, so for x2, x, for x1, 0. So when we do that, we get y minus b over x is equal to m. So we get that y minus b equals m times x. Right? And then if we work this just a little more, by a little more I mean if we add the inverse and negative b to both sides, we get y equals mx plus b. Wow, we get slope-intercept form. It's crazy. So how can knowing about an interception in football help you remember the definition of y-intercept? So think about it, right? The quarterback's throwing the ball to this receiver, but this DB right here on the y-axis reaches up, catches the football. Right there, intercepts it. All right, slope-intercept form of a line. We can use that for non-proportional linear relationships, because if they're proportional, we talk about direct proportionality, which is y equals mx. So non-proportional y equals mx plus b, right? So this part right here, based on our work in earlier chapters, this should go by really quickly, guys. Super fast. All right, so example 1, y equals 2/3 x minus 4. They want the slope. Slope is 2/3, and they want the y-intercept. Guys, the y-intercept is -4. It does not get any easier than that because we're using y equals mx plus b. All right, so we get some sample problems to work. So y equals -5x plus 3. For b, y equals 1/4 x. I'm going to write -6 as plus -6. And in c, we get y equals, so negative x is really an invisible -1 plus 5. All right, so our m is -5 in a, 1/4 in b, -1 in c. Our b is 3 in a, -6 in b, 5 in c. Guys, it can't get any easier than that. All right, example 2, write an equation of a line in slope-intercept form. If we have a slope of -3 and y-intercept of -4, guys, y equals -3x minus 4. It can't get easier than that. And the reason I want to say that is because we've already talked about this before. We've done a lot of this work. So most of this should be reviewed. Now, if you didn't get the stuff before, if you're fuzzy on it, well, now's the time to get unfuzzy, right? Now's the time to make that stuff sharp. So here they want us to write an equation in slope-intercept form for the graph shown. So they show us a graph. Now, our slope had better be negative, right? This thing had better be negative up here. because it looks like our line is sloping down, falling down the stairs, falling down that hill right there. So they tell us right there with this dot where y-intercept is at, it's right here. So we can count up 1, 2, 3, 4 units. So the y-intercept is at 0, 4. So our b is 4. Now, what is our slope? So if we drop down 1, we go over 2. If we drop down another one, we go over 2. Drop down 1, go over 2. So we're dropping 1 and going over 2. So we're rising -1, running 2. So our slope is -1/2, guys. Y equals -1/2 x plus 4. Boom. All right, they want to know if we got it. I hope you guys have this. Because we have an equation that we have to come up with for this line right here. Now, I hope you see that right here we are sloping up, right? Falling up that hill, falling up the stairs. Now, if we look here, we see that we come down 2 units. So that means 0, -2 for a y-intercept. So our y-intercept is -2. So y equals something x minus 2. Now they give us another point up here. In order to get there, we have to go up 1, 2, 3, 4, 5. So we have to go up 5. And we have to go over 1, 2, 3. So our slope up 5 over 3. So y equals 5/3 times x minus 2. So 5/3 x minus 2. Okay, now they want us to write an equation for E in slope-intercept form. If we have a slope of 3/4 and we have a y-intercept of -3, guys, it's like a 5-second problem. If you weren't there before, you need to be there now. This should be something you absolutely blow right through. Okay, interpret the y-intercept. When an equation in this form applies to a real-world situation, in this form, y equals mx plus b, slope represents rate of change, y-intercept represents our initial value. All right, so right here, when they tell us that student council is selling shirts and we see that our graph starts at 0, 20, they say that it costs $20 for the design and $5 to print each shirt. And they tell us that our equation is 5x plus 20. All right. So step 1, find the slope and y-intercept. So slope is 5. Y-intercept is 20. Step 2, graph it. That's 0, 20 right there. And then write the slope as 5 over 1. That's fine. So 5 over, because really what that means is we go up 5 and over 1 unit. So this would be 125. Right there is what that means. And that's how you can sit there and build your graph. All right. And then they want us on number 5 to interpret the slope and the y-intercept. So, I mean, you tell us literally, right, the cost to print X shirts is given by this equation. So our initial cost is $20. So whatever we're paying just for that initial design is $20. And then every shirt that we want to print costs us $5 per shirt. All right. And they give us a problem to work through now after taking a look at this one. So the problem we need to take a look at deals with taxi fare. Okay, so they give us this equation for taxi fare. 0.5x plus 350. So that means we're going to start up here at 350. So we're going up 50 cents, right? So that'll be $1, $4. So 2, 4.50, 3, 5, etc. So graph the equation, step F. I graphed it, check. G says interpret the slope and y-intercept. So 50 cents. So they're saying X is number of miles traveled. So how do we do taxi fare? So it's 50 cents per mile. So 50 cents per mile with an initial fee, $3.50. So the Y-intercept $3.50 basically means as soon as you get in a taxi cab, you owe $3.50. All right, that's what you owe just for getting in a taxi, and then 50 cents per mile on top of that. All right, let's take a look at guided practice. All right, we have to state the slope and y-intercept, graph it, and then interpret what they represent. So it should be pretty easy because they give us, guys, they give us the equation. If they give you the equation, guys, once again, if you can read this, you've got it. Why don't you rewrite this, right? Because this looks like y equals b plus mx. Why don't you rewrite it like y equals mx plus b? So if you do that, you're going to get y equals negative 40x plus 254. All right, so we're talking about a 254-page book, and Liam can read 40 pages in 1 hour. All right, so this is the equation for how many pages he has left to read. So what do these things mean? Well, so B is total number of pages in the book, and M is number of pages he reads per hour. All right, we need to graph it. So if we start out at 254, so 254 is going to be our peak, and then we're going to keep dropping until we get to zero down here, right? So we have 1, and whatever minus 40 is, what is it, 214. All right, so you just keep doing it that way. So what is the slope? Negative 40. Y-intercept is 254. Easy, 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 guys. You should be absolutely just blowing right through this assignment. Write an equation in slope-intercept form for the graph shown. All right, cool. Check it out, guys. So we have 0, negative 6, 3, negative 2. Okay, so y equals mx plus b. So we have two routes, right? So one, so m equals y2 minus y1 over x2 minus x1. You can certainly do that. Check it out. Check it out. So we have 0, negative 6. We have 3, negative 2. Okay. So y is negative 6. X is 0. B is negative 6. So 0m equals 0. 0 equals 0. Huh. Well, that seems a little strange. Let's try the other point. Let's try that. So y is negative 2. This one looks like it's going to work nicely right now. So negative 2 equals 3m minus 6. Because y-intercept is minus 6. So if we add 6 to both sides, 4 equals 3m. So m is 4/3. So y equals 4/3 x minus 6. So just be careful if you want to plug this right in to that y equals mx plus b formula, because we got ourselves into a little bit of a situation with that. So you got 0m equals 0. So that's just something that you want to avoid. So use the other point. And if you did this way, you would have seen, right, negative 2 minus negative 6 over 3 minus 0. So you would have seen 4 over 3. So we end up at the same place. What about number 3, guys? How does the y-intercept appear in these 3 representations? Table, equation, graph. So in an equation, the y-intercept is right here, it's our b, right? So like y equals 3x plus 5, y-intercept is right there, right? So on a table, let's see here, so on a table, you look for values. So let's say 5, 6, 7, 8. So our y-intercept in a table is the place where x is 0 and y has a value. What about on the graph? Well, graphically, it's the place where a graph crosses the y-axis. That's the y-intercept. All right, so we're just blowing right through this, and I hope you guys are doing really well on this because this is a review. 6-7 is really, it's a review, should make you feel good about what you already know. And if you don't know the stuff because you didn't get it earlier, this is your time to get it now. All right? Because what we're doing in 1, 2, and 3 right here is we just have to list the slope and the y-intercept. Okay? Slope is 3. Slope is -3/7. Y-intercept is 4. Y-intercept is -1/7. Over here, you have to do a little bit of detective work because you have to bring that 3x over. And you see that the slope is -3x and b is -4. Guys, so easy. So easy. You should be breezing right through this. All right, all these problems breezing right through. Now we just need the equation. All right, so our equation is y equals mx plus b, guys. This should take you, I should be able to say it slower than you can accomplish it. Right, so as I'm saying, it should be done already. You should be finished now. Are you still working? Beat me to the punch, guys. You should be finished much faster than I can get this thing out of my mouth. So you should be done and maybe eating breakfast or something right now, because I haven't started to write these down yet, but it's gonna be fast, right? Because our slope is -3/4, our y-intercept is 2, bam, our slope is 5/6, and our y-intercept is 8. It's that easy and it's that fast. You have to have it, guys. You have to have it. All right, so here we have a negative slope. Start out at 0.5, and they give us 3/4, right? So we know it's going to be negative. So y equals m times our x of 3 plus b. So 3m is -1, m equals -1/3. So y equals -1/3 x plus 5. Okay, if you don't like that, once again, you can say y2 minus y1 over x2 minus x1, m equals -1/3. Either way, you end up right here for y equals mx plus b. On number 7, 0, -12, and they give us 8, -2. So y2 minus y1 all over x2 minus x1. So we get 10 over 8, 5 over 4. So y equals 5/4 x minus 12. Please, please, please make sure you're getting this stuff just about that fast. It should be that fast for you. All right. So 8, we have to graph and then interpret the slope and the y-intercept. All right. So we have 1,000 minus 65x. And we're talking about distance remaining in their trip. So that means they start out 1,000 miles, right, from their destination. So they're going from Philly to Orlando. So essentially, right here, Philly is 1,000 miles away, right? And once we get down here, this is Orlando, because it's 1,000 miles from Philly to Orlando, and we're going 65 miles an hour, right? So what's 1,000 minus 65, right? 935. So 65 times 10, 650. So let's say, so 10. So 1,000 minus 650. 350, or just graph a couple of points. Just graph a couple of points. Okay, so our slope, -65, That's our slope. Our y-intercept is 1,000. All right, so the equation represents the distance remaining after X hours. All right, so Philly to Orlando. So what they're trying to tell us right there is, so 1,000, so our y-intercept is, that's a distance from Philly to Orlando. They're saying that distance is 1,000 miles. And they're saying that what's happening is we're covering that at 65 miles an hour. So if we start out 1,000 miles away from Orlando, after an hour, we're 65 miles closer. Then 65, 65, 65. We keep getting 65 miles closer after every hour that we travel. All right. Let's take a look at 9, 10, and 11. Graph each equation on a separate piece of grid paper. So 1/3 x minus 5. And let me actually go these this way since we have to graph it. 9, 10. So y equals, so 1/3 x plus 5. Okay, always start with the y-intercept. I think I mentioned that in class. So come up here to 5. That's the y-intercept. And draw your line. So what's happening is you're going up 1 and you're going over 3, right? So that'll be 3, 6. Boom. That's it, guys. That's it. 10. So y equals negative x plus 3/2. Always start off. So 3/2, guys, is really 1.5. So you start off there. And since your slope is -1, so down 1 over 1, right? So down 1 over 1. So we have 1, 1/2. That's how we do it. All right, so 11, y equals -4/3 x plus 1. So come out here, come up to 1. So -1, 2, 3, 4 over 1, 2, 3. Because our slope is -4/3. So that's going to be 3, -3 right there. So plot your y-intercept first and then follow your slope. So down 4 over 3. Guys, that's in a bit of practice, man. We are rocking and rolling through this thing. All right. Let's see. Okay, total cost of any number of tickets at 7 tickets for $5. All right, so let's see here. Get ready here for this one. You have to use the picture. I think I put that. I don't know if I kept this or if I tossed this. So if I kept this picture in for your work, so you see 7 tickets for $5. So if you tried to graph that, so we'd have 0, 0, so $5 out here, 7 over here, right? So if we have y equals mx, so our slope right here will be 7/5. So y equals 7/5 x plus 0. Y equals 7/5. For an all you can ride, it's just y equals 25 because here 25 says you pay that. Doesn't matter, you can ride 1 ride, 2, 3, 4, however many, doesn't matter. $25 gets you all you can ride. So like I said, I'm not even sure if I kept that force or not. So let's take a look at higher order thinking problems. Number 13, what is the slope of a line that has a y-intercept, no x-intercept? So y-intercept, but no x-intercept. That's going to be a horizontal line. So our slope is 0. Our slope is going to be 0. If it has a y-intercept, no x-intercept. Our slope is going to be 0. Because that means it's not going to touch across the x-axis. Then they ask us to reason inductively, what is the slope and vertical intercept? What is the slope and y-intercept of a vertical line? We actually saw this at the end of 6.6. I think it was number 25. So if we have ourselves, say out here at x equals 3, we have a vertical line. All right, so right here, so let's say, so x equals 3, I don't know, y equals 2. X is going to be 3 if y equals negative 5. So we would have, so y2 minus y1 over x2 minus x1. Division by 0, which would make this thing undefined. So in terms of a slope, so our slope right here, we don't have one. It's undefined because we have division by 0. Your calculator is going to give you an error. And in terms of y-intercept, as you see here, we don't have a y-intercept. There is no y-intercept there because straight line is not going to touch across the y-axis right there, that vertical line. So we're not going to have a y-intercept right there. Okay, number 15, which equation best represents the graph shown? So we have ourselves positive slope. So we can get rid of a and b. Yes, we have a, b, c, d. So negative 3x, negative 4x. So those are out because our slope is upward. Onward and upward. So y equals 3x plus 4, y equals 4x plus 3. Well, let's take a look at our y-intercept. So the y-intercept up here, 0, 4, 3x plus 4, guys. 3x plus 4. Boom. Let's go ahead and do extra practice. Okay, slope and y-intercept. So 16 is done for us. What is going on right here with this one? Let's take this back that way. There we go. So 16 is done for us. 17, y equals 1/2 x minus 6. Slope is 1/2. Y-intercept is negative 6. 18, y minus 2x equals 8. Put it in y equals mx plus b form. That means you bring the negative 2x over to the other side. So now our slope is 2. Our y-intercept is 8. Please, so I know I had a couple of people earlier in the year who tried to tell me and to tell the class, when we talked about this in class, that the slope would be 1/2 x. No, it's not. It's the coefficient, guys. It's just the number that's out in front of the x, just coefficient, all right? We're going to breeze through these next ones. So write an equation in slope-intercept form. So y equals mx plus b. And they give us the information. So in 19, they say our slope is 1/2, our y-intercept is 6. For 20, they say our slope is negative 2. So I'm sorry, y equals negative 2x. Our y-intercept is 3, so y equals negative 2x plus 3. 21, we have a slope of negative 3/5 and a y-intercept of negative 1/5. It's that easy. Extra practice 22. Okay, graph and then interpret the slope and y-intercept. So we have y equals 15x plus 35. So the graphing part's going to be easy. So start out 35, go up. So plus 15, so 50, and then 2, 65. All right. Interpret the slope and y-intercept. So $35 rental fee for a boat. So if you're going to rent a boat, that's, so interpreting the y-intercept, so 35 is the y-intercept, that's the fee to rent a boat. And then $15 an hour for usage. So $15 what it costs you per hour to rent the boat. So $35 is rental fee, and then how many hours you're taking the boat out, it's going to cost you an additional $15 per hour. So you want the boat, 35 bucks. You want it plus an hour, 35 bucks plus 15. 10 hours, 35 bucks plus 15 times 10, all right? 23. Similar, y equals 15x plus 37. What's the context here though? Temperature in degrees Fahrenheit based on the number of chirps a cricket makes in 15 seconds. Huh. So 15 seconds is our slope. Graph the equation, estimate the number of chirps cricket will make in 15 seconds if the temperature is 80 degrees Fahrenheit. All right, so 0.37. And then we have, so we graph it up to 80. Yeah, something, right? So let's come in here. So 1. So after 15 seconds, so 15 seconds, we have, say, 1 chirp, mx+b, so 1 chirp, 15 seconds, 15 plus 37 is 52. All right, so 2 seconds, 30 chirps, 30, 37, 67. Right there. All right. So how many chirps will the cricket make in 15 seconds if temperature is 80 degrees? Well, y is equal to 80. So 80 is 15x plus 37. Take 37 over. So 43 equals 15x divided by 15. So you know what that is? That's not quite going to be 3, but 43 over 15 is kind of close to 45 over 15. So it's going to be approximately 3 chirps in 15 seconds, approximately. Okay, 24. Still rocking and rolling on this thing. Real equation, slope-intercept form for the table shown below. So 0, 5, 113, 221, 329, 437. All right. Good news is we have, why is this, I don't know why this thing is like freezing right now. Okay, so 0, 5. And it looks like we're going up 8 each time. So every time I go up 1 on the x-axis, I'm increasing by 8 on my y. So that tells me y equals 8x plus 5. Boom. Okay, let's take a look at this now, guys. 25, test practice. Which statement could be true for the graph below? We'll learn 1750 if his sales are $10,000. Let's see here. So what do we actually start out with? So we start out 0, 500. And it looks like we have 20 and then 3,000. So 20 and then 3,000. So it looks like out here, sales in thousands. So it looks like the 20 matches up with 3,000 right there. So if we did y2 minus y1 all over x2 minus x1, we get 2,500 over 20, which would give us a slope of 125. So y is 125x plus 500. So which could be true? A, if she sells $10,000 worth of goods, she's going to earn $1,750. And you actually kind of see that on the graph. You can go over and see that that's about where the 1750 is at. Nothing else makes sense when you look at an equation y equals 125x plus 500. Nothing else is sensible at all. Okay, so let's go to 26. Jackie has 20 postcards in her collection. She decides from now on, every time she goes on vacation, she's going to buy 8 postcards to add to the collection. Total number of postcards y can be represented y equals 8x plus 20. So what does the slope represent? And they told us right there, they say every time she goes on vacation, she's going to buy 8 postcards to add to the collection. So the slope represents the number of postcards she's going to buy for each additional vacation that she goes on. So FGHI, so total number of postcards, no. Number of postcards when she began collecting, no. Number of vacations? No. The slope itself represents number of cards that she's going to buy on each vacation. All right. Hit 27 should take you all of about 5 seconds. Write an equation in slope-intercept form for the line that has a slope of -2/3 and a y-intercept of -4. There we go. All right. Review, guys, really, really quickly. Solve each equation for D when C is equal to 0. Okay? So D is equal to 10. All right, that's 28, 29. So -5D equals 0 plus 10. D equals -2. 30, 0 minus 6D equals 24. So D equals -4. Okay, 31, so equation for C when D equals 0. So 10C equals 40, C equals 4. 32, 0 equals 2C plus 10, C equals -5. 33, -4C plus 0 equals 24, C equals, so 24 divided by 4 is 6, but we need negative times negative, right? So C is going to be not just 6, it's going to be -6, right? What about 34 and 35? Let's take a look at those. Okay, are these things proportional? Let's take a look at this, guys. So 5, 6, 7, 8, 20, 24, 28, 32. Well, we saw this before. So if they're proportional, then y equals 4x would work for this. So 4 times 5 is 20, 4 times 6 is 24, 4 times 7 is 28, 4 times 8 is 32. So yes, these are proportional, and our constant of proportionality is 4. On 35, we have 10, 15, 20, 25. So we have 70 cents, 105. It's 35 cents. 140. 35 cents. 175. 35 cents. So 35 cents every time we go up by 5. So that means every time we go up 1, we'd have an increase of 7 cents. So that would mean y equals 0.07x. 0.07 times 25. So 140, 35. Yeah, that works right there. So that is proportional. And our constant of proportionality is our slope, guys, 0.07. Okay, so let's see quickly about this inquiry lab slope triangles right here. So Dante's ordered the plan shown to build a skateboard ramp. Each unit represents 1 foot. All right, so for Dante out here, so we have 2 units up and 6 units out. So he wants to expand the ramp, keeping the same slope. He wants to extend the base of the triangle an additional 3 feet. So how tall is this going to be? So our slope is, right, we rose 2, we ran 6. So our slope is 1/3, right? So if we start out at 0, 0, y equals 1/3 x. So if we want our x to be 9, so y equals 1/3 times 9. So if he goes out 3 feet here, he's going up another 1 foot. All right, so the ramp, if it comes out here an additional 3 feet, it's going to be 9 feet long, and it's going to be 3 feet high. All right. So investigation for the graph shown above. So they just take us through how we got there to that point. And then they say select any 2 different points on this line, label them D and E. Draw another triangle. Is the slope of D the same as the slope of AB? So basically we could take any points out here, right? So we could say, right, so 0, 0, 1, 3, 2, 6, 3. Now we could take any of those points, and the slope is going to be the same as our initial slope, right? So our initial slope. So y2 minus y, 1 over x, 2 minus x, 1, 2 over 6, or 1/3. So everything is going to give us the same slope if we take two of those points. So let's see, so collaborate, because this is really the first page is all about. It's just an exploration of this one problem at the top. Really short and sweet and to the point right there. Work with a partner, draw two right triangles for each exercise using rise, run, and proportions of the line. What do you notice about shape and size of the pair of triangles? Exercises 1 and 2. All right, so 1. So y equals negative x plus 2. Negative x plus 2. So down 1 over 1. Down 1 over 1. So negative x plus 2. So we could draw a triangle out here. So we have 0, 2, 2, 0, right? We could have, let's go, so if we went out here, right, down 1 over 1, so we'd have 3, negative 1, so we could have triangle that way. So we'd have 0, 0, 0, 2, 2, 0, 0, 2, 0, negative 1, 3, negative 1. Right there. Shape and size of the pair of triangles. So same shape, different sizes. So these triangles are similar. Similar. Right there. So, so we went up 2. So right here, so we have 0, 2, and a 0, negative 1. So that's 3. So then over here, so out to 2. So out here to 3. And this distance right here, so 2 and 2, 3 and 3. Yeah. So 2 parts to 3 parts. So they're similar triangles, guys. Similar triangles. Now we can see the same thing in 2. So y equals x plus 1. So they're similar because they're proportional. All right. So their leg lengths are related in a proportional way. All right, so x plus 1. So come up here, so we can have right, a little teeny tiny triangle there. Let's get another triangle and let's get it right up here. So these triangles, once again, they're proportional, so they're similar triangles. So they have different numbers, right? So leg lengths, they're different numbers, but they're proportional to one another. All right, and the reason why they're proportional to one another is because they have the same slope. They have the same slope. All right, so we drop 3, move over 3. Drop 2, go over 2. All right, so up 1 over 1. Right, so if we went up 3, we'd be going over 3. So it's the same slope each time, guys. Okay, number 4, use math tools. Triangles in activity are called slope triangles. Complete the graphic organizer. We're writing 3 observations about slope triangles. I'll leave you to do that on your own. And how does graphing slope triangles on the coordinate plane help you analyze them? So I'm graphing a slope triangle on the coordinate plane. Really helps me see if the triangles are similar or not, right? So we talked about similarity and we talked about congruence. So similarity, they're proportional. So congruent triangles are going to have legs that are the same length. Similar means they're going to be proportional. So you can kind of see that visually when it's set up on a line like this. So that's nice because that visual aid is always helpful in math. Guys, that's it for the week. That was 6-7. Watch this video. Make sure you go back and watch 6-5 and 6-6. See you on Tuesday and Thursday.